Hey everyone, today we are solving LeetCode problem number 94, binary tree in order traversal. So in this problem we are given a binary tree and we have to do the in order traversal of that binary tree. So what is in order traversal? In order traversal, firstly we have to process the left part of a tree, right part, then root, then right of a tree. In the in order traversal, let's say this is our tree. So this is our root and this is the right subpart and the left subpart is null. So in this in order traversal, firstly we are going to process left part, then right part, and then root part and then right part. So this is our in order traversal. So if we have to process this tree, so what would be the result? The left part is empty, the root is 1, this is written here. Then we will process the right part. In the right part, the root will be 2, left is 3, right is null. So left, then root, right is null. So 1, 3, 2 will be the in-order traversal of that tree. So in the recursion form, how do we write that? So firstly, let's say if we are on the left side, which is null, we are just going to return null. We don't have to do anything. If we are at a node root, if it is a root, then just print it or maybe process it, then move to the right subpart. So if we look at the code, if root is null, returning null, terminating case. Otherwise, in order the left part, completely left part, then print the current node, in order the right part. So in this way, we are firstly going to process left part, then the right part. Let's try this example over 1, 2, 3, 4, 5, 6. In this case, this is the left part, this is the right part, this is our root. So firstly we are going to process left, then right, in between root. Root is 1. So 1 is processed. Now let's try to process the left part. In the left part, root is 2, left part is 4, right part is 5. So left, root and right. Left, root and right. This is our left part. On the right side, root is 3, right side is 6, left is null. So left is null, then root, then right side. So 4, 2, 5, 1, 3, 6 is our in-order traversal of this tree. Now we have already done this we using recursion, like processing the left part, then root, then going to the right side. Now we have to do it using iterations without using recursion. So if we have to do that using iteration, we are going to process the same way. Like in any example, we will be given the root of a binary tree, but we have to print the leftmost node first. So we have to somewhere keep track of these nodes. So for that to track these nodes, we are going to use stack, because in our recursion example we anyway going to use recursion stack. So in this way we have to manually use the stack. So we have put 1 in the stack. Now what we'll do is we have to go to left. We'll put 2, now 4. We will put 4 into the stack. Now we will further, if we go to the left, which is null. If we have encountered null in the left, it means this is the leftmost node. So in-order traversal is left, then root, then right. The leftmost part first. So current pointer is at null. So in this way we are going to pop an element from our stack and going to print that. Okay, so we have printed 4 and 4 is processed. Now we will move current to the right, but right of 4 is also null. In this way, if right of 4 is also null, in this way we are um, going to previous call, which is 2. So now we have to pop 2 from the stack and print it. Here it is behaving like a root. left and right, and then left root, and then a right should be printed. Now let's see what happens. 2, we have popped 2, and we will move to the right. After moving to the right, we will just keep on checking whether there are elements in the left or not. But there are no element in the left, so we are going to print 5. In this way, we are going to process this task. Let me first quickly write down the code for that so that you can get more idea. So here, this is the code for our iterative approach. We will keep on adding element till we have left element. So like current is pointing to the root. We will keep on going to the left because ultimately we have to print the leftmost element. So if we are at null, it means that the previous one is the leftmost element. We don't have any element in the left, so that element is going to be printed. So now we will pop that element. We popped 4 from the stack and then process that element and add it, like, and move the current pointer to the right of that stack. Okay, so the right pointer is now null. If the right pointer is null, like we don't have to move any like any location left to that. In that case, we should be pointed to the previous call, like, which is 2. So 2 is going to pop in the next call. It will see current is null but stack is not empty. It means we will make another iteration, but current is null, so we will just directly pop that element from the stack, which is 2, and then process its value, move to its side. So current pointer is now at 5. So 5 will be processed. So now we are at 5. So we will add 5 till the left extreme. So now 5 is added to the stack, and now current pointer is to the left of 5, which is null. It means pop the element from the stack, process current value, and move right. Now pop the element from the stack, which is 5 is popped, and processed its value, and now move to the right of the stack, which is null. Okay, so now current is null but stack is not empty, so this is not going to run. We are just directly pop the element from the stack, popped 1 from the stack, printed here, and now move the current to the right of the popped element. Okay, so current element is now at 3. Okay, now in the next iteration our stack is empty but current is not empty, so we will keep on adding current till left extreme. So added 3 into the stack, moved current pointer to left, which is null. Okay, so this type is null. This iteration is done, or current is equal to stack.pop. So we have to pop the element from stack, which is 3. Now just printed the value and then move to the right. So current is now at 6. Okay, on the 6 we are going to do the same process. The stack is empty but current is not empty. So while current is not equal to null, stat.push current and move to the left. So added 6 to the stack and move the current pointer to this null value. Okay, now if it is null, so we are going to process these 3 instructions. Pop the element from the stack, which is 6, and then process its value, add it to the resultant array, and then move to the right. So we have processed all the elements by now. So now in this case, current is null and stack is empty. If current is null and stack is empty, it means we have processed all of our element. So this is our in order using iterations. So this was our recursion method. This was our iteration method. So let's try to quickly code this problem. Do the in-order traversal using recursion first. So we want a resultant list to store our answer. Now we'll do the recursion using root to this tree, and in the end we'll return result. If while doing the iteration, we will keep on adding our current element. So private void inorder tree node root. We have to inorder root dot left resultant dot add root dot value. Now inorder root dot right. For the terminating case, if root equal to null, we have to return our from our recursion. Let's try to submit. Submitted successfully. Now let's quickly code the recursion approach. Now let's say first we initialize our result list. Now let's take a stack. Now we will also take a current pointer, which will current point to our current node in the tree traversal route. So as we discussed, while current not equal to null and stack is not empty, what we'll do is we will keep going to the extreme left because it is in order. While current not equal to null, stack dot push current and current equal to current dot left. Okay, now we are at extreme left. Here we can safely print that element current equal to stack dot pop. So we are adding all the element in the stack. We just pop that element and we have to process that element. Result dot add current. Now move to the right. Current equal to current dot right. If current dot right equal to null, in that case we are going to pop another element because this loop will not work. If current dot right is something, in that case we will move to this block and we will move to the extreme left. In this way we are going to do the Inorder Traversal. Now in the end we can just directly return result. Let's try to submit our sample test cases. We got some error. Result dot add current dot value because result is a list of integer. 132. While current is not equal to null or stack is not empty. Whether we have any one of these two value, it means we will going to process this element. There should be or not and. Okay. Sample test cases are passed, submitted successfully. Time complexity and the space complexity in both the solution is going to O of n, the number of nodes in the tree. Thank you guys.